Hello friends, I have explained design of hot mix asphalt with wrap material in my earlier video, and this video is available in both English and Hindi. Today I shall further explain this procedure by taking two example problems. The design of hot mix asphalt with wrap material is a three-step process. The first step is gradation of the aggregate. And here we use wrap material. Wrap material can be in any proportion, but IRC suggests 30% wrap material to be used, and therefore you need to add new aggregate to the wrap material. Now this new aggregate can be in the form of RAM also, that is reclaimed aggregate material, or it can be altogether new aggregate. Then after proportioning of this new aggregate with wrap material, the second step is to obtain the grade and quantity of the new binder. And for that, you should know what is the amount of binder in the wrap material and what is the viscosity of this wrap recovered binder. And what is the target viscosity in your design. If rejuvenator is to be used, then what is the amount of rejuvenator to be used, that is also to be estimated in this step. And once you know the grading of aggregates, wrap, RAM and new aggregate, plus amount of binder to be added, grade of binder to be adopted, and the amount of rejuvenator to be used, then the third step is to design the mix as per normal Marshall method of mix design as given in MS2. Let us take one example. An example is that wrap at site has a bitumen content of 3.8% by weight of total mix. The viscosity of bitumen extracted from wrap is 46,000 poise at 60 degrees centigrade. The target viscosity of the binder in the final mix at 60 degrees centigrade is 3000 poise. Gradation of wrap and new aggregate are known. Design the mix for 30% wrap material. So let us say this is the gradation of the wrap material. If we take example of DBM 1, grade 1, sieve size, and that is the gradation of wrap material. Now here you will use new aggregate to make this grading in the range suggested in the IRC code or in MORT specification. Now this new aggregate, as I told you, it can be altogether new aggregate or it can be RAM also. RAM, I again repeat, RAM basically means reclaimed aggregate material. So after removing the binder from the wrap material, the aggregate which you get, that is called RAM. Let us take this in this example that you have new aggregate of this gradation, and that is the range specified for DBM 1. So when you mix 30% wrap with new aggregate, the final grading should be near the midpoint of this range. In other words, you should select your new aggregate with such a gradation. Then when 70% of this aggregate is added with 30% of wrap material, then you should get a gradation which is close to the midpoint of this range. Let us say you mix these two aggregates and the final gradation which you get is 196.5. So this is the final grading which you obtain after mixing 30% wrap and 70% of new aggregate. Now once you obtain the final gradation of the mix, the next step is to find the approximate quantity of asphalt demand in the recycled mix, and that is calculated using this equation. P is equal to 0.035A plus 0.045B plus KC plus F. This is the equation given in MS20, where A is the percent of the aggregate retained on 2.36 size. Now 2.36 is here, so this is the passing, so retained will be 100 minus 32.9, that is 67.1. B is passing 2.36 and retained on 75 micron. 32.9 minus 4.8, that is 28.1. C is passing 75 micron and that is 4.8%. K is a factor which depends upon the percent passing 75 micron. If this value is 11 to 15%, then K is taken 0.15. If it is 6 to 10%, then we take 0.18. If it is less than 5%, then K is 0.2. So in our case, it is 0.2. F, default value of F is 0.7. Its value varies from 0 to 2 based on the absorption of light or heavy aggregate, but default value is 0.7. So if you put all these values in this equation, then P will be equal to 5.273%. That is the approximate total asphalt demand in the recycled mix. Now, once you know, this is what we call the PB. Okay, PB is 5.273%. Third step is to estimate percentage of new asphalt, new bitumen. And that is given by this equation. P and B is equal to 100 square minus R into PSB into PB upon 100 minus PSB into 100 minus 100 minus R into PSB upon 100 minus PSB. That is the equation to calculate new bitumen, requirement of new bitumen. Now here R is the 70 ratio of new aggregate. PSB is the binder in the wrap material, that is your 3.8% that is given. So PSB is 3.8 and R is 70. So this P and B, if you put these values here, PSB 3.8, R 70, this equation will be 1.012 PB minus 1.185. So for a PB equal to 5.273, the requirement of new binder will be 4.15%. Because 3.8% is already available in the wrap material. So when you use 30% wrap material and 4.15% new material, new binder, then the total binder in the recycled mix will be 5.273%. Now, this is the new binder, this is the total binder, and therefore percent of new binder in the recycled mix, new binder to total binder will be capital R, that is 4.15 divided by 5.273 into 100, and this is equal to 78.7%. 78.7% is the ratio of new binder to the total binder. Now the next step is to find out what should be the viscosity of this binder. You take a semi-log paper, on y-axis you have the viscosity on log scale, and here you have the value of R, capital R, that is percentage of new binder to the total binder. So this is, let us say, 10, 30, 40, 60, 80 and 100. And on y-axis 10, 100, 1000, 10 to the power 4, 10 to the power 5, 10 to the power 6. That is the viscosity at 60 degrees centigrade, and this is R. Now the target viscosity is 3000, that is given in the problem, in the example. So 3000 is somewhere here. Okay, so that is the target viscosity. You draw a line here. That is target viscosity of 3000. Viscosity of the wrap material. Viscosity of the wrap material is 46,000 poise. So 46,000 poise will be here. Let us say this is the point A. This is 46,000 poise. And the value of R is 78.7. So here is 78.7. So corresponding to this 78.7, if you make a point here on this target viscosity, this is corresponding to 78.7%. And if you join these A to B, let us say this point is B. If you join these 2 points and extend this point to meet this axis here, this is the viscosity of new binder. Here, just say this point. That is the viscosity of new binder. Say 800. You get the viscosity of new binder 800 poise at 60 degrees centigrade. So approximately Vg10. So you will be using Vg10 binder 4.15%, and when this Vg10 or the new binder with a viscosity of 800 is mixed with the wrap binder having viscosity of 46,000 poise, it will give you a target viscosity of 3000 poise. So that is the procedure of finding the viscosity of the binder. Now you have the proportioning of aggregate, wrap material and new aggregate. You know how much binder is to be added and of what viscosity this binder would be. Then the third step is to design the mix. And this design of mix is done as per normal procedure of Marshall method of mix design, where you prepare a specimen at different binder content ranging from 4.5 to 6.5 in steps of 0.5, determine the volumetric properties of each mix, and then find out the optimum binder content. That procedure I have explained, Marshall method I have explained in another video. You can refer that video. Now the difference here is that for each binder content, you should calculate the amount of new binder to be added and amount of new aggregate to be added, because this is the ratio by aggregate. But when you prepare the mix, you should know the ratio with respect to the total mix. And therefore, so if you remember, we found this equation that the proportion of new binder is 1.012 PB minus 1.185. Similar to that, you can find out the percentage of wrap. That is PSM. PSM is given by this equation. Again, this is 3.8, that is the binder in the wrap, R 70, and if you put these values here, it will be 31.18 minus 0.3118 PB. So this is the wrap to be added, percentage of wrap with weight of the mix. And PNS, new aggregate, New aggregate to be added will be R minus R into PB upon 100. So R is 70. So this will be equal to 70 minus 0.7 PB. Now you have all these three parameters in terms of PB. So you can prepare a table here that for a particular asphalt content or bitumen content, let us say 4.5, 5.0, 5.5, 6.0 and 6.5, what would be the values of new binder, amount of new binder, amount of wrap. So new binder P and B will be given by this equation, that is 1.012 PB minus 1.185. So for a 4.5%, it will be 3.37. For PB equal to 5%, it will be 3.88. And similarly, you can calculate for remaining 3. PSM is given by this equation, 31.18 minus 0.3118 PB. So this will be for a PB equal to 4.5, this will be 29.78, 29.62 and so on. And similarly, the percentage of new aggregate, that is 70 minus 0.7 PB. So this will be 66.85, 66.50. Sum of these three values will be 100. So that is how you calculate the percentage of each component to prepare the Marshall specimen. And after preparing Marshall specimen, you find out the optimum binder content. So that is how we design the hot mix asphalt with wrap material. Now let me just change this example slightly. Now all data are same, that is the mix is to be used, 30% wrap is to be used in DBM1. The only difference is now that this mix is to be laid on a heavy trafficked road. That engineer has decided that VG30 binder is to be used along with Rejuvenator. The viscosity of the binder extracted from the wrap, same 46,000 poise, and the target viscosity also remains same, that is 3,000 poise at 60 degree centigrade, and the new binder VG30 to be used with a viscosity of, let us say, 2400 poise. So first step is same, that you make proportioning of wrap material with the new aggregate to satisfy the condition of grading, and let us say 30% wrap is to be used. So 30% of wrap and 70% of new aggregate, that is the final grading. Corresponding to this final grading, you find out what is the approximate amount of the binder PB, and that also remains same, 1.012 PB minus 1.185. Now you know the viscosity of new binder. In earlier case we found this viscosity 800, but here this viscosity is known. Target viscosity is also known. Viscosity of the wrap material is also known, that is 46,000 poise. Viscosity of Rejuvenator is 1 poise. So what should be the amount of Rejuvenator to be used, so that when this VG30 is mixed with the wrap extracted binder, it will give you a viscosity of 3,000 poise. So we again go to the same chart. So on x-axis you have R value, capital R, that is the percentage of new binder with respect to the total binder, and on y-axis you have viscosity at log scale. So first you mark a point A here, that is corresponding to the viscosity of bitumen extracted from the wrap, 46,000, and this is the let us say target velocity, target viscosity of 3000 poise, and value of R is 78.7. So this is the point here, B, similar to what we did in the first step, in the first example. Join these, so you get the viscosity of new binder here. Now, when you are using VG30, you know the viscosity of the new binder, and therefore you need to use the Rejuvenator. And this is here VG30, 2400. So if this is point C, let us say this point is D. And you also know viscosity of Rejuvenator 1. So here is the viscosity of Rejuvenator. Let us say this point is E. So if you join this D to E and move from this point C to this line, you get what should be the percentage of Rejuvenator. That is the percentage of Rejuvenator. Let us say 8%. So you will be using 8% Rejuvenator having a viscosity of 1 poise, and when this Rejuvenator plus VG30 with a viscosity of 2400 is used in the wrap material, it will give you a target viscosity of 3000 poise. That is how you calculate the amount of Rejuvenator. Once you know that, all remaining procedures are same, all remaining steps are same, that you know aggregates now, you have the bitumen, the new bitumen, Rejuvenator, wrap material bitumen, and all are to be mixed. Again, you have to prepare that table, because corresponding to each binder content, your amount of new binder will change, amount of wrap will change, and same table you have to prepare here and carry out Marshall method of mix design to determine the optimum binder content. So that is how we design the hot mix asphalt with wrap material. I have taken 2 examples here explaining the procedure. Thank you very much for watching this video. If you have any question, you can write in the comment box.